Welcome to The Explainer. Today, we're going to talk about something so fundamental. It literally dictates everything, from when you wake up in the morning to what season it is outside. And it all comes down to two simple movements of our planet. Have you ever really stopped to think about it? Why does the sun rise and set every single day? Why do we even have seasons? Well, these aren't just kids' questions, you know. The answers get to the very heart of how our world works, and it all boils down to two kind of cosmic dances. So, let's dive in.
So, here's what we're going to cover. First, we'll look at our spinning, orbiting world. Then we'll get into rotation and what causes day and night. After that, we'll tackle revolution and the Earth's tilt. That's the recipe for the seasons. And we'll finish up by looking at solstices and equinoxes. Sound good? Let's go.
All right, first things first. Let's start with the motion we feel every single day, the one that gives us our most basic rhythm, that constant spin that creates day and night. So what is rotation? Well, just picture the Earth spinning like a top. Seriously, that's the best way to think about it. It's spinning on its axis, this invisible line that goes right through the North and South poles. That's rotation. And how long does one full spin take? Yep, about 24 hours. That's what we call an Earth day. It's the planet's daily clockwork, basically. Now, because our planet is a sphere, a big old ball, the sun can only light up half of it at any given moment. So the side facing the sun gets daytime. And the other side, well, it's in darkness, experiencing night. And that line that separates day from night, that beautiful twilight zone, it actually has a name, the circle of illumination.
Okay, but which way does it spin? This is super important. The Earth rotates from west to east. And because of that specific direction, it looks like the sun, the moon, and all the stars are rising in the east and setting in the west. But they're not actually moving across our sky. We're the ones turning. It's all about perspective.
And you know what's really cool? This isn't some newfangled discovery. People figured this out a long time ago. This quote you see here is from the ancient Indian astronomer Aryabhata. He was talking about the Earth being round and spinning on its own axis more than 1,500 years ago. Just amazing. Okay, so that's the daily spin. Now, let's pull back. Let's zoom way out and look at the Earth's annual journey. Because this second motion, this is the secret sauce for why we have seasons.
This movement is called revolution. It's the Earth's trip around the sun on a fixed path, which we call its orbit. And this trip takes, as you probably know, about 365 and a quarter days. And hey, that little quarter of a day? That's exactly why we have a leap year every 4 years, to catch up.
So it's really, really important not to get these two mixed up. Let's just say it one more time to be clear. Rotation is the spin that gives us day and night. Revolution is the orbit that gives us our year. Simple as that. But wait a minute. Just going around the sun isn't enough to create seasons. Nope. The real magic ingredient, the thing that makes it all work, is the Earth's tilt. Our planet isn't sitting straight up and down. It's leaning over on its axis by 23.5 degrees. And, this is the key, it stays tilted at that same angle the entire time it's going around the sun. That constant tilt is, well, it's everything. Think about it. As the Earth orbits the sun, that lean means that for part of the year, the northern hemisphere is kind of angled toward the sun. Then, for the other half of the year, it's the southern hemisphere that gets to lean in. That's the whole game right there.
So this combination of orbiting and tilting creates these two extreme points in the year. Moments where one half of the planet is getting the absolute most sun it can get. We call these moments the solstices.
Let's take June 21st, or right around then. On this day, the North Pole is tilted as far toward the sun as it's gonna get all year. So what does that actually mean for us?
Well, on this day, the sun's rays are shining pretty much directly down on the Tropic of Cancer. The best way to picture it is like a flashlight. If you shine it straight down, you get a bright, intense circle of light. That's what's happening. All that direct, concentrated energy gives the northern hemisphere its longest day of the year, the peak of summer. And at the exact same time, the southern hemisphere is tilted away, getting less direct light, so they're having their shortest day, deep in winter. Okay, now let's hit fast forward. 6 months later, around December 22nd, the Earth has moved to the other side of its orbit. And guess what? The whole situation has completely flipped on its head. Now, it's the South Pole's turn to lean into the sun. Those direct solar rays are now hitting the Tropic of Capricorn. So it's summertime down in the southern hemisphere. They're getting longer days, more heat. And for everyone up in the northern hemisphere, it's the complete opposite. It's our shortest, darkest day of the year.
the winter solstice.
And this gives us a fantastic real-world example. It's why Christmas in Australia is a summer holiday. While folks in the Northern Hemisphere are dreaming of a white Christmas, people in Australia are often hitting the beach to celebrate. It's the same holiday, but a totally different season, and it's all because of that simple, stubborn 23.5-degree tilt.
Okay, so we've got the two extremes, the longest and shortest days, the solstices. But what about in between? What happens when we're not tilted directly toward or away from the sun? Well, twice a year, the Earth hits this sweet spot, a point of perfect balance. We call these the equinoxes. This happens around March 21st and September 23rd. On these days, the Earth's tilt is kind of sideways to the sun. Neither the North Pole nor the South Pole is leaning in. So where do the sun's most direct rays hit? You guessed it, right on the equator.
And the result is pretty amazing. The word equinox literally means equal night. And that's because on these 2 days, pretty much everywhere on the entire planet gets about 12 hours of daylight and 12 hours of night. It's a real moment of global balance.
So you can think of these dates as the big seasonal handoff. Around September 23rd, the Northern Hemisphere starts tipping into autumn, while the Southern Hemisphere is just bursting into spring. Then, 6 months later, around March 21st, they switch. Spring comes to the north and autumn arrives down south.
So, when you boil it all down, it's this simple. Our daily spin gives us the rhythm of light and dark, and our tilted annual journey gives us the beautiful cycle of the seasons. These two simple cosmic dances are basically the engine of our planet. They've created the predictable patterns that have shaped everything, from farming to festivals to the entire story of life on Earth. It really makes you wonder, doesn't it? Just how different would our world and our lives be without them?